Okay, I have to wait for the queue for the streaming. Okay, I'm good. So, welcome to Ignite, and thank you for this opportunity to talk about this topic. So, I'm Shweta. I'm a senior SDE with Microsoft in the developer experience team, and we primarily work with customers to understand their business scenarios and help them architect their systems, adopt cloud, and my focus is big data and IoT. So, before I introduce this topic, I wanted to give you guys a little background. So, when we all realized that we get the opportunity to come to Auckland, we were all excited. And my colleague John Gallant, if you've attended his session yesterday, he was like, "We should do something really cool," and he did something cool. He got these pharaohs and made them move and stuff, and I'm like, yes, I have to do a cool demo. And the pressure of being cool, and I realized I've never been cool in my life. Seriously, none of my jokes, people never laugh, they all fall flat. So I thought, let me just stick to what I'm good at, being serious. And I thought, like, we all when we talk about Internet of Things, Raspberry Pis, Arduinos, Neduinos, doing stuff, getting things to move, it all comes to your mind. But when we actually have to build a production scale applications, what are the things that we need to keep in mind? So this session, or objective of this session, is to take you through some of the things that I generally talk about or think about when I'm working with customers to build a production scale application. So let's be serious and let's get down to business. I just want to talk to you about this. This is everything that I can think of that comprises of in IoT. And I'll start from this corner and we'll go down to that corner. Are we cool? Okay, let's start from scratch. Let's just draw a mind blank. And for those who wanted to click a picture, don't worry. The slides are available, so you can get a snapshot of it. So let's just start from blank. Okay, let's just draw, because the moment we go on the internet and search, I won't tell which search engine because it might be contradictory, but you can you get to hear of so many things. There's so many things that are around IoT that sometimes you just need to take a step back and just let's start from basics. Imagine that we don't know anything about IoT. First thing that I think we need to do is identify a scenario. Now, most of the times when we go and work with customers, they say, great, we want to do IoT, and when we sit down on a desk with them, they've not really thought of what they want to do. So it always starts with identifying a scenario. You have a business problem to solve, and if it involves devices and sensors and stuff, then yes, it is Internet of Things, right? So we need to identify a scenario. Like I said, we'll start by identifying a scenario. Now, as a person, like I said, I'm a very serious person. I love going to office. Okay, I don't know why, but although we have work from home option, I just love going to office, getting dressed, sitting there, and having my coffee at the desk. Unfortunately for me, there's also another guy who loves coming to office. He's a tall, lanky guy, a business consultant, walks in with salt and pepper look, French beard, walks in with his business suit and tie, and walks into the office every day, and he sits right opposite me, and then he shouts. He picks up his phone and shouts, "Kitna garam hai idhar? Kya kar rahe ho tum log?" I'm sure you all understood what I'm saying, but basically he's saying, it's so hot here. Please do something. Just increase the temperature. Decrease the temperature. And meanwhile, the moment he says that, in 5 minutes, this is how I end up sitting. Seriously. This is a real photo taken by one of my colleagues. You can see there are 2 jackets. Just in case I forget one, I use the other one. But this is a problem I think that all of us have faced, right? I mean, one corner, and this is a very common scenario, it's a boring remote monitoring scenario, but let's just take this scenario. Obviously, the simplest thing would have done is we switch our places, but if we do that, then we won't have our scenario. So this is our scenario. Okay, let's get started. What if we want to change the draft of the air automatically based on the base temperature. It's a very simple thing, right? I mean, you want to optimize energy, and if you want to build it at a large scale, let's say I have a pretty big campus and I want to build it at a large scale, what are the things to keep in mind? And we through this we can actually apply these things in almost any scenario that we talk about. So I have outlined 4 steps that, like, if we break our steps, there are 4 steps. One, we have to create our data sources. So it's a basic of any system, right? We need to first get the data in to be able to start organizing, and in these data, in this case, our data sources would be sensors, or it could be multiple sources. Second one, once you have your data sources in place, we have to ingest that data, and there are serious things that we need to consider when we talk about data ingestion, because we would be doing it at a very large scale. Third step, once we have the data coming into the system, what do we do with the data, right? How do we make sense of the data? And once we made sense of the data, what's the action? What's the corrective action? So we'll follow these 4 steps for the scenario that we've just identified. So let's get to creating of data sources. Now, I'm not that bad. I have a demo, so but it's a slide heavy thing. So all the slides will be available. Just we'll just go with, you know, and please raise your hands and ask a question. Just stop me anytime. That's fine. So let's start with our data sources. Okay, there are 4 aspects that I think we should look at when we're doing data sources: the capturing of data, connectivity, the format, and security. So and there are various features in it, which we'll take one at a time and just go through in greater detail with respect to our scenarios. So let's look at data capture. Choosing the right hardware. Now, I am not an expert, and I'm still at this point doing a lot of research. There are like thermistors and sensors and stuff. Actually, let me just switch my laptop for a minute. So I came across this pretty cool white paper. I'll have the link in the slide that kind of talks about various sensors that could fit in different industrial scenarios. And for me, if you're like me, who really doesn't understand hardware too much, just get an expert. Just get an expert to choose your right hardware. So let's get back. And second is placement of devices, right? Because depending on the hardware you choose, what is the connectivity, what's the range, what are the connectivity aspects the hardware supports, then power and voltage. Does those locations have the required power and voltage positions? Is it somewhere in some corner where you can't really give them any power? Are they battery powered? How will you maintain them, replace them? There are a lot of these questions which I think getting a hardware expert to work with you would make sense. One thing that I want to really talk about is number of sensors. Okay, so this is a very important thing because it determines a lot of your costs and of course your long-term planning. So let's look at our scenario. We'll make certain assumptions. One assumption, let's say we have a floor with bays. Bays is basically just logical groupings, and on an average we need 1 sensor per bay, and each floor has 10 such bays, and each building has 15 such floors, and each campus has 50 buildings, and we've got 10 campuses. It's a pretty practical thing, right? I mean, there's nothing out of the ordinary here. And if you do the math, we get the number of sensors. Now, people who are math whizzes here will realize this is wrong. We actually need 750,000 sensors if you do a math based on this. So this should give you the sheer volume of thing that we're looking at, right? 750,000 sensors to manage the campus buildings for accurately drafting the air. Now, obviously you need to consider the cost that comes, and then that determines your hardware choice. For example, we're working with a startup who are monitoring their tires. Their customers are fleet management companies who want to monitor the tire pressure, and so they are looking at. They finally came down to a microcontroller which is custom made. I mean, they actually sat and made it, which is costing them less than $5, and because of the costs that they need to consider. Obviously, I wouldn't advise that for an enterprise. Please don't be penny picking over this, because ultimately you have to maintain. Imagine writing a code that sends data to cloud on a 64 KB microcontroller. They had to do embedded C. So all that needs to be kept in mind, and that really so the number of sensors is very important. That determines your hardware choice. Second thing is connectivity, defining the layout of your devices. How will they send data, whether it's going to be Wi-Fi, Bluetooth, Ethernet, then where will it be consolidated, because you don't want 750,000 sensors connecting to the cloud at the same time. And like this is the answer, will the sensors be connecting to the cloud? There will be scenarios where they need to, right? If they're, for example, these tire sensors, they're like 4 tires, 4 sensors with one hub that connects to the cloud. You can't really have a collation. And what are the protocols? So it also depends on what your organization's policies allows and what the hardware device supports. There are some hardware which don't support AMQP or MQTT, they'll support HTTP. So all of them are secured, it's just how you want to send data. Obviously AMQP and MQTT are much lighter weight protocols compared to HTTP and are more preferred, but then it depends on the hardware. So let's look at our scenario. Sure.
So these protocols are running on the wireless link?
Yes, yeah. They run on TCP, yes.
Any like Wi-Fi or Ethernet? Or
yes,
you can
yes.
run any of those things?
Yes. So his question was, do they run on wireless links? And the answer is yes. So let's take a look at our scenario. We have a floor, and we have bays, and we have one sensor per bay. So we'll just have a hub that sends all the data to the hub on that floor, and then that hub actually sends data up to a gateway for the building. Now again, you could have a gateway for each building, or you could have a gateway for multiple buildings if your buildings are interconnected. But if your buildings are far apart with no interconnections, then you could just have one gateway per building. To keep things simple, we'll do that, and we'll have this gateway which sends data out to the cloud. Okay. So data structure, I was thinking of JSON, although this I have added some more details to it, but we could probably have a JSON message that goes up. It could be a text, CSV, string, whatever we want to. Whether we send individual temperatures or should we send a collection, let's park this question. We'll look at it a little later. And should we do a compression? We'll also look at that a little later. Next thing to consider is frequency, right? What's the frequency at which you want to send data up? Okay, from at this point in time, I'm assuming the data is going to go to the cloud. Okay, unless you have a big infrastructure just lying idle with you, I would just recommend using the cloud. So what are the factors to consider? One is criticality. How critical is that data to you? And that determines your frequency. Then second, timeliness. If the data is sent say after half an hour and actually loses it becomes obsolete, then you obviously have to send it much before. So you need to determine the timeliness, the connectivity, because that device should have the connectivity to be able to send the data at that frequency, and the cost. And the frequency and message size are two critical factors that determine the cost, and I will run through that in a little later down the line. Security, let's talk about at the ingestion level as well. So we've kind of captured our requirements, that this is what our data. We'll have a building, each floor has 10 sensors, and then we have a building gateway that's sending data. Let's look at ingestion. some factors to consider: location, throughput, security, compression, collection parsing. Actually, to be honest, first, I hadn't added location earlier. I added it later because I had a hilarious story. So I was working with one of the biggest automobile manufacturing companies in India. They manufacture cars and trucks, and we went to their foundry, which is basically a manufacturing unit that manufactures iron casts that are finally used for creation of engine parts. So it's very critical for them to have their cast monitored well, because if a cast is not accurate, the engine part fails to be made in the exact specification. So they had a pretty good setup. They already had Rockwell automation everywhere, and they had a dashboard which shows the number of casts, and they had additional informations like jolting pressure, melting temperature, pouring temperature and stuff, which was actually not captured, but at least the system was spitting it out. So we decided that we'll start capturing that information, and we'll be pushing the data into the cloud for them to start, using it. So since it was a pilot and limited to that foundry, we had to decide the location. I mean, though that is like a heavy hat area, so we couldn't really place it near the server. So we finally thought we'll put it near where the employees sit, and we just had a simple desktop with that could send data out. Now every evening the data would just stop coming. So we told them, listen, the data is not coming, and then they would say, okay, maybe it's in the policy of shutting down the PCs, we'll take the PC out of that policy. But still the data won't come. And finally they realized, imagine you're in a foundry and with all those hydraulic presses, and then suddenly you have a PC with internet on it. What would you do? So people would just go browse Facebook and do whatever they want, and then good Samaritans shut it down. So it was it was a pain, because then what they had to finally do was just take off the keyboard and the monitor and mouse and everything and just have the box. So that won't stop many people, but thankfully it stopped them. So it's very important to know where your gateway is going to be there. It should be accessible, it should be maintainable and stuff. Second is throughput. Now throughput is, let's look at our throughput requirements. We've got 750,000 sensors. So I've written a code that sends data out, and I just took the message size. So that message size in bytes is 240 bytes. And so if you look at, I have various scenarios outlined. So if you look at direct scenarios is where each sensor is sending data directly at 5 minutes, or each sensor is sending data at 30 minutes, or each aggregated messages, each gateway is aggregating messages for all the sensor and sending at 5 minutes or at 30 minutes, and then I did a compression. So I took message size in bytes, I took the frequency, I multiplied it to get the throughput requirement a day, and I'm putting IoT because it's easiest to calculate the cost. But if you look at the cost, you can see the difference, right? If I'm sending a direct message at every 5 minutes, my throughput requirement is 4.9 GB, almost 5 GB a day. But if I compress it, aggregate it, reduce the frequency to 30 minutes, my throughput is 23.44. Okay, it makes a tremendous impact. Your frequency and your message size makes a tremendous impact on the costs that could occur for data ingestion. So these are two things to keep in mind, that when you start doing an IoT scenario, first thing to keep in mind is that do a calculation of your throughput and your message sizes, because data size is not going to be a problem. We can deal with GBs and TBs of data now and petabytes of data. What we can't deal with is this kind of throughput. We can, it's just that you need to have more money to deal with it. So this is obviously the most ideal scenario. So we'll do a compression and aggregation and send data every 30 minutes. Other thing to keep in mind is secure ingestion, and one of the reasons why I chose IoT Hub. Have you heard of IoT Hub? If you can show of hands. Few hands. Okay. So Azure IoT Hub is basically Event Hub, which is for hyperscale ingestion, but we have this whole device management layer around it. So it makes it very easy for me to add device, register devices and send data, and it adds a layer of security to it, because when a device is registered, it gets a unique identification key and it does not send the key over. It creates a SAS token with that key and sends and signs the data with that SAS token, which is then sent over to the IoT hub, and it manages. Because let us say if we really had the scenario of 750,000 sensors, we won't want to get into managing those devices, at least the authentication and authorization. So IoT hub can just manage it on its own, it scales, it is offered as a service. So I chose IoT hub as one of the options. Now, so there are two ways to authenticate. One is you register the device, it gives you a key, security key, and you use that key to generate a token and send the data out. Second option is this device can register a certificate, self-signed certificate. Now, the advantage of self-signed certificate is that the certificate resides on the device. So even if you have a program that can that somehow gets the device key and tries to generate the SAS token, it won't work. You have to have the certificate. So it adds another layer to security. So what we'll do, sorry, yeah.
What's the requirement for having that certificate on the device? Should it be running in particular OS or?
No, it's just a self-site, will run in Linux or Raspbian or whatever. So it works with any most of the. So his question was, is there any OS requirements for certificate? I said no. It's just most of the OSs support that. So this is what we'll do. We'll have a base sensor that sends temperature data to the floor, and then the floor hub sends it to building. The building gateway consolidates, compresses, generates a SAS token and sends the data to IoT hub. Okay, and we'll just replicate it across all the buildings. So we now this is all, like I said, all of this is easily available. This is just a code that is easily available on our documentation site that generates the SAS token. The reason I show you this code is it's a simple Node.js code which you can use. And so there's something I want to talk about: decompression and deaggregation. So IoT hub by default does not support it. So if I compress a message and send it to IoT hub, it will not decompress automatically. Or if I send a collection of messages, it will not deaggregate automatically. So we had to write something. So what we've done is, me and a couple of colleagues, we've written this simple deaggregation and decompression code, which we've just put it on GitHub. The repo will be public maybe by next week. So you're free to just use it. It's available under open source licensing. So it's a simple code that takes in the data. It could be deployed as functions, which I'll touch base later, or any console application, written in Node.js, and we'll be coming up with Python soon. So this is the generic deaggregate. So it just takes in a collection, reads the pattern of the collection, because every array will be different, and then it just breaks it into messages, which you can apply it at scale. So our data ingestion is in place, right? We have the gateway which will get the data. It will generate the SAS token. It is sent over to IoT hub, and there's a function that I've written which is taking that code. So basically, each gateway is going to get data from all the temperature sensors, compress it, aggregate it, and send it over to IoT hub. IoT hub, the message will be read by the function, and it will deaggregate and decompress. Okay, so that part is clear? Great. So let's just do a little bit of, let's see how we do it. So I've written a simple Service Fabric app. The reason I wrote a Service Fabric app is because I had wanted to test it to scale it to like maybe 50-60 nodes and generate data at very large scale. It just works smoothly. I'm not going to do that because I'm running it out of my laptop. There was some issue in deploying it. But this Service Fabric app is just simulator, and I tried to implement simple JSON which is sending all this. Actually, let me just go down and show you. It sends 120 to 150 messages together it's an array, okay, this is, okay, whatever, it's an array of messages, and it's a simple code. It just sends the data out to IoT Hub. Let me just remove this. And I've set up an IoT Hub here. So when you can define your scale and tier, so that determines how many messages. For example, I've selected an S1 with 400,000 messages per day. If anything higher, I might have to answer my manager. So it's very important to define your scale, and the scale is determined by the throughput requirements. So you also need to set up your partition. So if you say I have a throughput requirement of 1 GB per second ingress, you cannot really get that by setting it up and configuring, but it is possible because we've tested 1 GB per second ingress, but that's like really huge. So I've set this IoT Hub, and let me just show you a diagram which I made. So what our demo is going to do is it's going to send data into IoT Hub, and I have this functions which is going to receive data and send it to two outputs, an event hub which I want to do real time processing, and a storage. So this is my function app. So the function app is serverless compute. So basically I can just upload a code and have it define a trigger. So here it's IoT Hub as a trigger. So the moment it starts getting messages, it will start running the function. So let me just show you the logs. So if you see, the logs have already started coming. It's giving me the, okay, it's too many logs, but let me just clear. So the logs have already started coming because the data is going. So it receives, and then it just, sorry, I had to reload the code, so I'll have to find the exact piece. So if you see, it's sending data to an event hub, and it is also sending data to an output blob. So it's a very simple code. It took me 3 days to set this whole thing up, and I will make this available on GitHub, so you can just download, deploy it yourself, and test things out for yourself. So okay, so our data ingestion is in place, and let's move to our third step, which is data processing. Okay, now so this is actually, in a sense, it's one of the easier things to do, because once you've solved the problem of getting all the data in, then it's kind of working with any other large data set, right? So some of the decisions we need to take once the data is in is, okay, what are we going to do with the data? Maybe we need to check if the sensor is sending data above or below a benchmark temperature, right? I mean, and whether maybe we should store that temperature and use it in the further step, or we should get an alert if a sensor is not working. Maybe we should capture the manually corrected temperature. So if someone has manually corrected the temperature, that means it's not efficiently setting the right temperature. So we could take a lot of such decisions. But technically we end up having two paths. We have a hot path where we want to do real time analytics, and we have a cold path where we store the data and we keep adding to the repository, and then we want to make sense of that data. So there are a few options that I have outlined that we could use for actually comparison and data processing. One is Spark. It's one of the most preferred platforms for doing a lot of streaming data processing, because it provides high compute. But and I think it is well suited for really complex processing, where you have to, for example, do natural language processing. So let's say I have Twitter feeds coming in millions and millions of, by the way, the highest ingestion was from Twitter at 500,000 messages per second. I think that's the highest that has been achieved right now. So processing that kind of messages and then checking out the sentiment, that could be a good scenario for using Spark. Or you could have your own custom API or application that processes it on a virtual machines, or deploy it on app services, which is a SaaS offering. And functions, like I said, functions, it can just start processing messages. But the problem with functions is that it will not scale. So to a level where if you really want quick real-time stuff, I wouldn't recommend functions, because functions do not scale to that extent. You need something that could scale. And I really like Stream Analytics because it's efficient for conditional checking. So if you have simple conditions, okay, if it crosses a benchmark, if it's giving this value as an alert, if it is doing certain things, so you can actually just write simple T-SQL queries. It handles the scale, it manages all the data coming in, it runs the conditions and gives the output out. And for us, I think for our scenario, this right now is the best suited one. So let's add the processing to our scenario. So if you see, we have functions, the function sending data to Event Hub, and then I am taking 2 stream analytics jobs. One which is checking if the sensor is available or not. Second, if it is exceeding or benchmarking temperature, and I'm pushing everything into a storage. I also have a function which is simply reading from the Event Hub and pushing it into a storage. So you could ask, I could technically do all of this in one component. I can write one single app that does all of this, but the problem is scale. Okay, so when you are looking at really production level applications, you would want something that takes care of small things, the microservice architecture itself, and can individually scale. So this is what I would do, and this is the hot path that we were talking about, and this is the cold path that we just dumping data in the storage. So I'll just quickly show you data processing. So since we have the data that's coming in, I've written a simple query. The hot path that I was talking about is just, it's a simple query. It is just concatenating the building names, and it's giving me the floor numbers. I'm just doing something so that, and I'm pushing it into a Power BI because which I accidentally closed. So let me just open it. So what's happening is, if you look at the input, it is taking the input from an Event Hub, which the function is deaggregating and sending data to. So we're sending an array with 120 sensors data, but it'll deaggregate and it'll receive it as individual sensor records. And then I'm pushing the output to a Power BI dashboard. So this is my Power BI dashboard, and you can see the data that's coming in. So I've added a little bit of location data to it. It's giving me an average temperature. So it was very simple to set this up. And today, if I deploy that Service Fabric app in a 30-node cluster and have data being sent at maybe 3,000 messages per second, it will work without me needing to do anything. Of course, I have to answer the bill, but apart from that, I don't have to worry about scaling the infrastructure and doing. And this is what we need. We need components of things that we don't need to worry about. So this is so we have data processing in place, and we can take action, which is basically, once we know that a base sensor records that a temperature is above benchmark, what do I want to do? I would probably want to send it back and inform. It could be through a live dashboard, but IoT Hub also allows you to send data back to the device or messages back to the device. So you could technically have a function that reads and sends it back to IoT Hub and says, hey, this particular gateway, this particular sensor is not working, and maybe that gateway could alert, start blinking, or we just show it in a live Power BI dashboard saying the sensor is not working. So there are various ways to do it. And other thing, of course, is what do you want to do if the temperature is out of our boundary? We could just again send it back to the gateway, and then maybe there could be a code that triggers and automatically change the drafts of the air. Now again, that's engineering, and I might not be the right person to do, but I know it is possible to do that. You can, so in fact, there was another demo I had actually made. I couldn't bring it up. It was a fan and I created 2 boxes with a fan which could move from one box into another after IoT Hub sending information to it. It was too bulky, and I'm here for 4 weeks for a holiday after this, so it didn't fit my wardrobe. So I just thought, chuck it, So like I said, we could just trigger an alert, send an instruction to move the air draft, or update the live dashboard. So I would add that to our scenario. If you see, Does this work? Yeah, it works, but I wonder if you can see it. So basically I'm adding it back to the IoT hub. The IoT hub goes back and says, hey, there's something wrong with the dashboard. So in action, I've already shown you the Power BI, so I'll skip this. So I know I said 4 steps, and I think we still have time. Yes, we don't have time. We have time, a lot of time, right? So what if we add stuff to it? Okay, I have this big sense of data that's coming with me. What if I can start predicting stuff? You know, what do I do with it? So let's go beyond reactive analytics. Reactive analytics was where I sense something wrong and then I go and react to it. But let's go beyond that. So we have temperature data, right? We have it by base, by floors, by buildings, and by campus. We have it captured every half an hour. So we are actually capturing rich data. And then we also are capturing when was it manually triggered. So we know that the moment it was manually triggered, it was not efficient. And then we also can get the external weather details because we have weather APIs that tell us weather every now and then. It might be difficult for Auckland where it rains in 5 minutes and then there's sun in the next 5 minutes, but most of the world it works fine. So we have the occupancy, so we could get the occupancy based on attendance system and stuff. And why don't we use all that to build a temperature prediction model? I could actually predict what should be the ideal temperature today based on all of these factors. So that model could feed in these 3 things in addition to our temperature data. I could hook up with Outlook calendar. I could figure out all the meeting rooms. I could figure out how many people are invited to those meetings. So in all probability, this particular bay will be occupied by so many people around this during these times. So let me just accordingly run and tune my model and predict the right temperature. And it just sets. So let me add to this model. I have this beautiful diagram where I will add everything to it, which is very similar to what you saw, right? But I'm hoping now you are going to understand what we're going to say. We'll quickly run through this whole model one by one. So we have this, all the buildings, they send the data to IoT hub. It's compressed, aggregated data, and we've realized how important compression and aggregation is to reduce the costs. And then I have this, this simple first function which is going to take that data, decompress, deaggregate, and then send it to a event hub. And then from that event hub, I am storing the data in a blob storage, which is very cheap. It's like 2 cents per GB per month, which is going to store all the data. And then I have 2 jobs, one which is checking if a sensor works or not, second which is checking if the temperature is in the benchmark or not. And in stream analytics, you have something called as reference data. So you can combine your real time with reference data. So our reference data would be benchmark data. It could, to start with, it could just be the benchmark should be 24 and higher, above 28 is too hot, below 24 is too cold or something like that. Obviously everyone has their own benchmark, but let's say that's the benchmark. I could just store that as static data and have stream analytics refer to it each time it wants to, or I could hard code in the query. I would still refer to it and I'll tell you why. But so the stream analytics takes in that data, checks if it's in the benchmark range, and if it is not, then it sends an alert to an event hub again. I have this function which is listening in. The moment it decides, it gets a message, hey, there's something wrong, there is something out of the ordinary. It goes back and it sends the message back to the IoT hub, which contains the sensors data. Now this IoT hub, now I have this field gateway. Now I don't want my gateway buildings to sit and monitor everything because they're already doing the job of sending data and I just want to do them. So I can actually have a field gateway, which we call, that can monitor the messages that are coming in. And then this field gateway could actually go back and inform the facilities monitoring system that there's something wrong, or if it's coded appropriately and if I mean, if people allow it, it could actually instruct the movement of the air cooling systems. So once, and then if I get a stream analytics where the temperature is not working, I could again go back and let the IoT hub know. Now I have all the data being stored in a blob storage. Now we spoke about doing getting the predictive models. What if I get all the HR attendance systems data, which is basically all the employees who attended that day and all the meetings that were held and stuff like that. And I can use the Azure Data Factory. I recommend that because it allows you to copy data. It has this extensive copy activities that you can create. It can copy at regular scheduled intervals. You could probably do it every end of the day or something, but it scales. So you don't have to worry about running those schedulers. It'll just manage, it'll give you alerts, it'll let you monitor if there's something wrong. So I could get all that data and store it in another blob storage or the same, it doesn't matter. Similarly, I can write a simple functions. Now you've seen I've written functions everywhere because it's very quick. These are very small things that I've done, but you can always have your own web application or console application running on a VM, it doesn't matter. I have tried to use as much as possible everything that is hosted and available as a service, so I don't end up maintaining those VMs. So I get all those current temperature data, everything into a storage blob from a weather API. Then I have a model which is in my machine learning. That model can take data from all the history of data, combine it with the attendance, combine it with the weather. So there were 100 people in the office and this was the weather, and these are the number of times it was manually changed, the temperature, to suit the audience there. So maybe what is the right temperature, and this model could go back and actually update the blob storage with the benchmark data. So my benchmark, which was a static 24 and 28, could actually be a moving benchmark which depends on the weather outside, right? I mean, this actually came to me from, so how many of you traveled to the US are from the US? Okay, few, so I can say this. So basically whenever I go to the US, I just hate the way they manage that temperature. So no matter how beautiful it is outside, how sunny it is outside, it's just super cold inside. Okay, and we were in a off-site and we had these few girls who wore bright sunny dresses and they were standing at the reception, and I'm like, wow, you're like, very comfortable in this. So they're like, oh, don't worry, and they had a heater below their legs. so they had this crazy lovely weather outside, which is perfect, and then they have a super cold conference room, and then again they have a heater which is going to heat up this thing. So that's when I thought that it is something that we really need to consider. So anyway, so my benchmark data could be updated based on everything, weather conditions, attendance, and then I have a really smart system working which could give a perfect temperature to everyone. And the best part is this, everything is hosted, everything is as a service. I don't have to worry a bit. Now I'm exaggerating, obviously you will have to worry, but it takes away a lot of your pain of building a really large scale systems. So to be honest, I am at the end of my slides, and the message that I want to drive is that when you're thinking of building an Internet of Things applications, there are these things that you should keep in mind because they heavily determine your costs and actually the success of your project, whether it will succeed. It's possible to really optimize it based on a lot of these decisions that you take. With that, I can answer questions if there are any. Yes, please.
I've got a question about blob storage. So that seems to be a common pattern that I've seen in a lot of IoT solutions. What's the rationale behind choosing to store sensor data in blob storage? And are there any other alternatives? And can you talk about maybe something?
Sure. So the reason why a lot of us choose blob storage is because you can load that data into, say, a HDInsight Hadoop cluster, and do further processing. It's much easier. But you can use data lake, you can even use, if you have your own Hadoop system, you can use HBase, which is again cheap. So the idea of blob storage is you can store large amount of data at extremely low prices. That's the only rationale that we use, and any technology that addresses that would be super useful. So we have data lake, and data lake is one of the technologies, but I would still use blob storage because the data is not really that sensitive, something that it's okay. But blob storage also provides the 3 copy, it maintains 3 copies automatically locally. You can also make it geo-redundant, you'll make 3 copies available geo-redundant. So I think I'm pretty much set. That's one of the reasons. Yes?
You mentioned the limitation of the scalability of Azure functions.
Yes.
What's the limit like? What's the guideline of using functions?
So functions, Azure functions are actually, when you create a function, you set the VM size or compute size that you want. So you're limited by that compute size, and there is a upper limit on the compute size that you can set. So if you're getting 3000 messages a second, functions might not process all the 3000 messages at the same time because it can't scale. But if, like I said, if you're okay if the message comes in a little later, like this temperature data, that is fine. If it comes 5 minutes later, it should be okay, because IoT Hub can retain your data up to 30 days. So you don't have to worry that if the data comes in and it's not read immediately, it's lost. It's not. It's retained up to 30 days. You can always go back and read it again. So let's say if you're not written your functions, you've written a web application on a VM which went down for some reason, you can just note when it went down and then go back to the IoT Hub and go back and do it. So 30 days is configurable. By default, it's 1 day. So. Yes?
Is there a query interface for blob storage, like you can query like in SQL, where you can put in conditions, but you're looking at blob storage?
Not really. I mean, that's an interesting thing to build actually, where you can query, but so blob storage are access to APIs. But if you have large amounts of data, what we do is we use Hive. So we just link the blob storage we create a HD Insight cluster or Hadoop as a service cluster, we link the blob storage, and then we use Hive to use SQL based querying to access the blob storage. It uses the underlying blob storage. Another good thing about that is, let's say you're doing this processing, which is maybe once a day, once an hour. You don't want the Hadoop cluster to be running 24/7. HD Insight fits well there because you spin it up, you do the processing, and then you can just bring it out. You can just crash it. You can just shut it down. You'll stop paying for it, but your data is retained in your blob storage. You had a question?
Yeah. I was wondering, most of these systems are perfect for the near real-time processing, but we need real-time processing for some systems. Are there any tips and tricks which can make it, closest to the real time?
Yeah, to be honest, that's something that we keep striving to achieve, but real time, if you have like real time processing, do it on-prem next to the system. Unless we have super fast, whatever said and done, we all talk about, oh, you can send it to the cloud and we can do stuff. But if you want action within, like for example, if you have we had this scenario where they want a person coming in to be recognized and scanned, and then figure out if they're an authorized person to be in that bay or not. So they could have just used someone else's card and then walked in. Now, if by the time the data goes up, then we have one service that probably is calling a cognitive service, doing a face recognition, and comes back and say that person would have done their job and walked off, right? So you want something that triggers an alarm, an alert right there and then. I wouldn't recommend pushing it to cloud. Exact real time, just do it on-prem. There's no other way. I mean, in fact, we had another scenario. We had one of these electrical grid making companies in the US. So they have this, it's funny, I couldn't believe I was hearing this, but they said they have this problem of people shooting at the grid, because when people are frustrated, they go to this electrical grid and they shoot at it. I have no idea why would anyone do that, but they do that. So they want to be able to be warned when first shot is fired, it captures that vibration. I'm like, please don't put it on cloud. You know, the person would have shot at least 100 times and walked away before you realize. Just do it, there and there. I'm sorry? Okay, that would be smart, right? You know, just a gun comes out and then it's ready to shoot you back. So, on premises. So, any other questions? Cool. So, I hope you found this session useful, and please, I'll make sure I include the GitHub repo link. I'll make it public next week. So just all the code will be available. You can just download and set it up and try it out yourself along with the slides. Okay. Okay. Thank you so much.